Hey everybody, it's good to see you. It has been a while since I have made a video in 2021. Like, this might be my, I don't know, second one. So a lot going on at work, and I've started my first class at Boston University, and what hopefully will turn into a master's in software development. So the amount of time I have left for YouTube, stuff like that, is limited, but I enjoy making these. So when I can, when I find some time, I'll keep grinding out some of these videos. So today we are going to talk about dependency inversion. And this plays into, the theme what we've been working on, which is design patterns in Apex. Because a lot of design patterns, right, use dependency inversion. And you will hear a lot of times for software design that the key principles are solid, right? Single responsibility, open closed, Liskov substitution principle, interface segregation, and dependency inversion. For today, I'm going to go straight to the end, and we're just going to talk about dependency inversion. And I think as we continue to make design pattern videos, I will sprinkle in some of these other solid principles and how they apply to what we're doing. Really, when we talk about dependency inversion, though, all we're really saying, if we go back to the video I did a while back on programming to an interface and not to an implementation, of what that means, that's what we're talking about, dependency inversion. But we're just going to do a short, quick video here today, spell it out, and hopefully it's useful for you. For a lot of the code bases I look at, I feel like the fastest thing they could do to improve would be, right, to be programming to interfaces and to implement dependency inversion, so their code would not be so tightly coupled. But let's get into IntelliJ. Let me get that going here, and let's take a look at that. All right, so what we have, I'm going to actually get rid of that. So I started writing a couple things. So first off, we're going to write we're just going to play around with shapes today. We're not going to do any serious code. We already have a class called Shape Manager with nothing in it. We're going to create 3 classes, and I'm going to call it circle. Okay, and we'll say public void. Sorry. Draw a shape. You can see these are all going to be pretty trivial, and all we're going to do, there's not going to be any logic in anything we do today. We're just going to print stuff out to the console, right? So, drawing a circle. All right. Let's make a rectangle. All right. Public void, draw a shape. All right, and we're just going to say system.debug, drawing a rectangle. All right, and we're going to make one last square. All right. Okay, so the same thing. Public void, draw a shape. Debug. Drawing a square. All right. Now we've got this. So we have our 3 shapes, right? And we have our class I've called Shape Manager over here. And we'll say public void get shape, and we'll give it a parameter of string, shape name. Okay, and this kind of if else is what I see a lot of. If shape name equals circle, we'll just say so. Circle equals new circle, and we'll just do circle dot draw shap. Let's go fix that right now. That's going to bug me. Do Shift F6 Use one of the great features of IntelliJ to refactor. All right. Back to Shape Manager. All right. Circle.draw shape. All right. Now, else if shape name, say square, and square equals new square, and square dot draw shape. All right. And then we'll just do else, and we'll we need to do the rectangle, right? Rectangle equals new, whoa, what did I do there, huh? New rectangle. Rectangle dot draw shape. Okay, so this is what I see a lot of, right? So this is what, if you remember, going back to programming to an interface, right? We have not programmed to an interface here, which, if we remember talking about, is just saying programming to a super type, to a super class, right? We have programmed to implementations. So we are the Shape Manager class is very tightly coupled to circle, to square, and to rectangle. It is super dependent on all three of those classes. So it's not very flexible. And, you know, and also, I mean, one of the things we strive for, one of the solid principles is open for modification, closed for modification, open for extension, the open close principle. So this one, anytime we added a new shape, we added triangle, right? I don't know, rhombus, we would have to go back in and crack open this get shape and do something else. And we're also dependent on all of their draw shape methods. So what we have here is, let me open up my before and zoom in a little on that. So this is our current state, Shape Manager, and Shape Manager is using and is dependent on all three of these classes. And this is, I said, pre-dependency inversion. So this is our current state, right? That's what we have going on, Shape Manager, and it is tightly coupled with all three of those classes. So what we want to do to fix this, to make much more flexible code, is, let's get rid of that for now, we don't need it, is let's implement first of all, we're going to make a shape interface. New Apex class, make it an interface, and shape. Yeah, I'm going to call it iShape, just to be clear. All right, iShape, okay. And void draw shape, okay. Okay, so now what we're going to do is in each one of our shape classes, circle, square, rectangle, we are going to implement the iShape interface. And because we already, and all of them have the draw shape method, this will be pretty fast and simple. We won't really have to change much except to put that in. So we're going to say circle implements iShape, okay? And alt. Rectangle implements. Remember, if we want to use an interface, we have to use the implements keyword. Or we use extends for abstract and virtual classes. And square implements iShape. Okay, so now all three of our classes implement iShape. And what this does now, right? Polymorphism, right? We now have a super type. All of our concrete shapes are inheriting from the shape interface. So we now have a super type. So let's go back in. And what we're going to do, we're going to change our Shape Manager class. And we're going to get rid of all of this. So bad. Okay. And now, because we have a shape. So first of all, what I want to is the big thing to understand, and go back, I have some videos on polymorphism on interfaces, but if you haven't watched them, all right, so I'm just going to say shape equals new circle, right? And why isn't illegal assignment from circle to shape? That should work. Probably just taking a second. We're going to push this up. Oh, because it's an I shape, right? Yeah, how about that? I shape. There we go. Okay. So the shape interface, right? While we can't instantiate an interface directly, it can, any class that implements it, it can hold a reference to. So that means our I shape over here on the left side of the equal sign can hold a reference to a circle, a square, or a rectangle, because all of those have, and because they've all implemented the draw shape method, right? So we would just do shape.drawShape. And so let's tell you what, in fact, let's just do this in Anonymous Apex just to show you what it looks like right now. So we'll just let instead, if that's going to run for a little bit. All right, so I'm going to have a sip of coffee while we wait for our CLI connections to update, because I'll probably be way too lazy to edit this out later. There we go. All right, let's give ourselves a little real estate. Just a refresher on interfaces, right? I shape equals new circle, all right? And shape dot draw shape. All right. Let's just run that. Why do we have an invalid type I shape? Did it not get deployed up to Mark Benioff's supercomputer? Bear with me, everybody. It's free. It's on YouTube. What do you want? We'll wait for this to run. I'm going to have some more coffee while we wait. Okay, let's run that. Debug only. All right, so you can see, and this is what I'm talking about, right? Polymorphism, interfaces. I shape on the left, right, can hold a reference to anything that implements the shape interface. So if we then, in our shape manager, right, get shape, and what we're going to do is, because remember before, we were dependent on all three shape classes. Now we're just going to be dependent on the I shape interface. So we're going to say, and what I'm going to do here is this is something I like, a personal preference, instead of using if-else's. If I'm using no argument constructors, is to use the Salesforce, the Apex type class. So I'm going to say type T equals type dot for name shape name. All right. So we're going to create a type within it. So if we pass in the class name, in fact, you know what? To make that clearer, let's call it class name. Should have just refactored, because now I got to change it down here. Class name, class name, name. Okay. So that's our first step in using the Apex type class. I think it is much simpler. Maybe there's a little more cognitive overhead to it than using if-else's, but again, we will not really be, I'm going to say, closed for modification, but open for extension, right? And then I'm going to say shape equals, and we've got to cast this, right? So we're going to put a shape in parentheses there, T dot new instance. All right, so we're saying, hey, you know what? Give us a new instance of the class name we provided, cast it to shape, and cast it to I shape, the second time I've done that. Okay, I shape, and then let's just shape dot draw shape. All right, so now hopefully you can see this, right? Even if I go in, we go later and we add, right, triangles, rhombuses, pentagons, whatever, any shape we add, we don't have to change our shape manager class. We don't have to change our I shape interface. We just have to implement the concrete class, right? And again, I'm going to emphasize, I really do like to use the type method. I think it's something Apex developers should use more of. But it does only work with a no argument constructor. So if our if our shape had a constructor, right, of any kind, like this would not work. So we would have to have a different type of factory to implement them. But so let's compile this. Change metadata. Alrighty. So always the awkward parts of maybe someday, this is my dream, right? Someday they'll give us a local version of Apex and we won't have to sit here and wait 20, 30 seconds sometimes to do something pretty trivial. All right, open up anonymous Apex. All right, now I'm going to say shape manager equals new shape manager. Okay. And I'm going to say manager.getShape circle. All right, drawing a circle. And where this gets even more powerful, right? This is a pretty trivial method, but if we wanted to, so before, right, like because where this really gets hard, and where I think it's really hard if you are programming to implementations, is if we want to return something. What if I had actually wanted to do is not, do draw shape in here, right? So let's comment it out. But I wanted to return the shape and let the caller implement, make use of the draw shape method. So think about it. If we were programming to those concrete types, and why do I keep doing that, right? You think by now I'd have realized it's iShape, right? We would have to have different methods, right? One method to return circles, one method to return squares. Then, business requirements change and we want to return, hexagons. We've got to go back in and all these methods that are really kind of doing the exact same thing, right? So let's go and we're just going to say return shape. All right. And again, let's deploy that up. Of our awkward pause. Time for me to drink coffee. All right. Still going. Come on, Salesforce. All right. Now, back to anonymous Apex. Let's take a look at that. And so, manager. Now we're going to say shape S equals. Did it again, didn't I? iShape. S in now, right? So S dot draw shape. All right. There we go. So if I didn't make typos, right? Now, if I just, I want a square. That's not how you spell square. I'm pretty dangerous if I could ever type. Control Enter. Drawing a square. All right. So what we have done is we have flipped over, and this is, if anybody, the tool I'm using is Plant UML, which has a very nice plugin for IntelliJ. Also has a plugin for Visual Studio Code. I think I'm becoming a huge fan of this for UML diagrams. Is we have done inversion of our dependencies. And what that means is it's not that we don't have dependencies anymore, but now our shape, what it means is everything is dependent on this abstraction. So our higher level class, shape manager, what we don't want is for our higher level class to be dependent on lower level classes. So instead, our shape manager is dependent on this abstraction, the shape interface. And also all of our shape classes, our concrete, subclasses of iShape are also dependent on that interface. So we have gone from, this is where it comes from, right? So we've gone everything like that to now we've inverted the dependence. So now we've got this abstraction in the middle, right? So that is the inversion, our dependency inversion. So again, I hope this was useful. I think it's a great concept. I think it makes your everyday Apex development much more flexible. If you found this useful at all, please give me a thumbs up. Let me know in the comments. If you didn't find it useful, let me know in the comments and tell me how we can make it better. And I will see everybody in the next time we make a video. So keep practicing, keep on getting better, and I'll see you next time, developers.